Hello and welcome guys. Today we're going to look at a circuit analogy, a way to explain what electricity or how electricity works. So we can think of the cell as a little house producing energy, and we can think of the current as little men carrying lunch boxes full of food. Okay, so here they refill their food at their house. And then when they pass here, they pass by the ugly witch's house. Okay, so they go all the way around here, and now unfortunately to get past the witch's house, they need to give their food. So what happens is the moment they pass the witch's house, they come on this side with a empty lunchbox. So there the lunchbox is full all the way here, full of energy, which the energy that they receive at their house, and then they go back and refill their energy, and then they come back and deliver their energy. Okay, so the electrons is represented by the little men. Okay, the cell is represented by the house. Here is the house of the witch. This is the resistor that steals their energy and uses it. Okay, and the house is the cell that gives the energy. So the electrons are transporting the energy to the witch. Okay, so a few things that we look in here. If we want to count how many men there is, if you think of a magnifying glass, a magnifying glass that can see inside the cell, and it counts the amount of charges per second, or the amount of electrons. Okay, so we're calculating the rate of flow of charge, and that's the definition for current. So we are counting literally how many of these little electrons or the current is passing by per second. Okay, and then we get what we commonly call, so here's the witch again. Can't have an analogy without a witch. Okay, very sad, unhappy. Okay, and here we have the voltmeter, and the voltmeter measures the difference in potential. So difference means you have to compare two things. And what the voltmeter does, it measures the amount of energy, the full energy compared to the empty energy. So how much energy has been delivered to this witch. Okay, so that's the basic analogy, and then we can upgrade it, okay, to incorporate an explanation for series and parallel circuits. Now, a series circuit is when there are two witches' houses in a row. Okay, so there is ugly witch number 1 and ugly witch number 2. Okay, and they're moving from this house all around, but now they have to share the amount of energy between the two, because they can't give all the energy to this one because they need some energy for that one. Okay, so if the witches are equally ugly, okay, they will share their energy equally. If this witch is uglier than that one, the uglier witch will have more energy, and the less ugly witch will have less energy. Now, the ugliness of the witches is a measure of the resistance, how difficult it is for the electrons to pass. So if it becomes difficult, they give more food, and the witches steal the food. The electrons doesn't eat it up. They're not stressful eaters. The witches, they throw their food to the witches. While the witches are munching the food, the electrons can pass. Okay, so when the current passes through in series, they have to pass by both witches' houses. Okay, the next type of circuit that we have is a parallel circuit. So a parallel circuit means there are two roads. Okay, now there's one witch and there's another witch. Okay, so you can either pass by the one witch or you can pass by the other witch. Okay, and what's going to happen is the electrons are going to make a choice. Some of them will pass this way, some of them will pass that way. If the witches are equally ugly, The current won't mind whether I pass that ugly witch or this ugly witch, it doesn't matter. So the current will split equally. So if there's 10 little electrons, 5 of them will go this way, 5 of them will go this way. But the electrons passing by this witch's house only have to pass by one witch, and they have to get to their house with empty hands. So what they will do is they will give all their energy to this one. So the 5 that pass this one gives all their energy, and the 5 that pass by the bottom give all their energy. So in parallel, if the cell gives 6 volts of energy, this witch is going to receive 6 volts of energy, and that witch is going to receive 6 volts of energy. Now let's speak about the fact if one of the witches is super ugly and the other one is not. The electrons would want to go through, this one is super ugly, so only 2 of them would want to pass there, and the majority would pass here, because these 2 just don't want to stand in the queue, so they'd rather pass there. They still each give their 6 volts, but the way in which they distribute is different. So the one with the higher resistance gets less current, the one with the less resistance gets more current. But overall, the electrons pass through only one witch at a time. Now, imagine there is a path with a witch and a path without a witch. So what's going to happen is, the moment there's a path without a witch, all the current will pass that way. They will reach their house with full bags, okay? And what's going to happen then we get a short circuit. So the current will have no limit, and they will start running, going very fast, because there's no resistance anymore. The current picks up, the circuit will heat up tremendously, and it will start burning your wires, and we call that a short circuit. Now, a short circuit in the house can create a fire. Okay, so the moment there is a path with no resistance, that creates what we call a short circuit. So to summarize, in series, okay, the resistance adds up. So the total resistance is equal to the one resistor of the one witch plus the resistor of the other witch. So each of the men are going to pass by 2 ugly witches, and the uglier the 2 witches, the more uglier they see. But the voltage is divided. So the total amount of energy that they receive is split between the 2 witches. Okay, let's ignore the resistance for now. But all the men, the whole current, passes by the one witch, and it's all the men that pass, or the current passing by the other current. So we call a series circuit a voltage divider, because the current is the same everywhere, but the voltage splits up. In parallel, only one of the witches is visited at a time. So each witch gets the total amount of energy that the cell can give, but in parallel, the current divides. They split up. Half go, or some of them go by the top, and some of them go by the bottom. And we call this a current divider circuit, because the current splits up.